Hi there. Thanks for joining my presentation. I'm Kate Simpson and I'm a research associate at Imperial College London and a visiting researcher to the Alan Turing Institute. I'm funded by the Lloyds Register Foundation under the Data Centric Engineering Programme and specifically data-driven design under uncertainty. And my project designed for retrofit, I'm looking to address uncertainty and explore opportunities for data-driven approaches to decision making. And I'm quite keen to bridge the technical and what's possible with the practical and what's useful for the industry and for decision makers such as householders, builders, local stakeholders. So my research that I'm presenting today is an early idea, which is informed by a literature review, a data review, and also some work quantifying uncertainty with data, which I found, which is openly available. And that led to me finding gaps in the data. So towards open and citizen-led data informing retrofit, informing dwelling retrofit strategies. So first of all, the declaration of a climate emergency might require energy researchers to work quicker and more collaboratively. And I really like this quote from a working paper, which followed an event that I attended earlier this year. And I agree with this, and this has underpinned my approach and part informed my approach of sharing research ideas before they're fully formed to get feedback from conference attendees. Meanwhile, I've also been taking inspiration from the Turing Way, which is it's an open book project and it's a collaborative, open source, community-driven guide to reproducible, ethical, inclusive, and collaborative data science. And it was co-created from the start. And while working at the Alan Turing Institute, I've learned that data science is much more than the technical skills. It's also about collaboration, sharing, making information open access where it's ethical to do so. And developers and programmers appear to be highly collaborative, part due to the availability of tools such as data repositories like GitHub, where they can share code and develop it among the community. And I think there's quite a lot that we can learn in the energy demand community from this. And I'm quite keen to explore that further. So my project design for retrofit, I'm looking at decision making of which measures to deploy to low-rise residential housing. And for me, yeah, there's a multiple range of options of measures that could be installed in houses. Retrofit typically includes the installation of low carbon technologies, including energy efficiency measures such as fabric insulation and low carbon heating, among other measures for ventilation control and potentially more. Because of the large variation in options and the large variation of buildings and occupancy patterns, I think some of the most useful lessons that we can learn are from retrofit examples which have been completed. And we have some data on this in the UK, but it's quite limited, and sometimes the methodology is different to other case studies. So that's partly informed this approach. Some of the data which can be collected post-occupancy from dwelling retrofit includes geographic location of the building and building characteristics in terms of the archetype, construction method, etc. The retrofit products installed, the energy performance, and this can be measured pre and post. Thermal comfort, which can be derived from air temperature measurements, velocity, and also occupant perception. Indoor air quality control methods and how user-friendly these are for the householders, heating behaviour, as well as other factors which are important to householders, such as how the house and the measures look, how much it cost to install, how long it took, and what the process was. And I think there's an awful lot that we can learn from householders about the homes which they're living in, which we can use to inform future retrofit strategy. One example of research which has informed this approach as well is my PhD, where I had 14 case study households, and I collected pre and post data before and after their retrofit. I only had a 3-year period, but some of them are keen to continue sharing data after that. And I think there's a certain type of householder who could be quite engaged with this type of approach if we empowered them to become so. Here are some examples of open data which I found. So for me, good examples have been research which has been shared by Loughborough University on Figshare, including Refit and Leader, and they included 20 houses each. And then also the Low Energy Building Database, which includes case studies across the UK, and householders have uploaded some data to that database. The challenge with it is that the methodologies can be slightly different, and it's still quite a low number of case studies overall. But I think we could use that as a basis to learn from and potentially combine some of the other national data with the case studies that we could collect in a citizen science project. So just to discuss and conclude, I'm keen to see more open information in energy demand and building retrofit research where it's ethical to be shared. I believe that empowering citizens could be one approach to do this, so that they can share data from their own home, and they become the gatekeepers of that information. I think this could progress knowledge of what works and what doesn't for the housing stock. And then I think that this could minimise risks for future retrofits. And I hope that this could accelerate progress as we move towards a net zero carbon housing stock. So thank you for listening. Questions and suggestions are invited, and I hope that you're interested enough to read the full paper.